So this is finishing up the partial fractions section. We're looking at 3.6 here, and where we left off was right here. So my goal is to rewrite this as I guess a composition of fractions, so adding fractions together to be equal to this. So what you'll notice is it's already factored for me as far as the denominator goes. So I just get to rewrite that. And my first fraction is going to be x squared plus 2. But notice it's a quadratic, so I want my numerator to be in the form ax plus b, a linear term. And then add to it x squared plus 2 squared. And again, it's a quadratic. It's a form of a quadratic, I should say. And so you have your linear term on top, cx plus d. So as I multiply everything by this denominator, so I still have 8x cubed plus 13x, I'm going to multiply that ax plus b. Now one of the x squareds plus 2 cancels with multiplying by this, but there's still another x squared plus 2. And then over here, all of this cancels just like all of it canceled over here, so I just have cx plus d on that. So as I FOIL or distribute, however you phrase it, we have ax cubed plus bx squared plus 2ax plus 2b, and don't forget about that plus cx over d. I'm trying to squeeze it right there. Hopefully you can see it all. So as I'm looking at this, I only have one x cubed term, and that has an a with it. Well, there's only one x cubed term over here, so that tells me that a has to equal 8. So as you look at the only x squared term over here, you see how there's no other x squareds? Well, there's no x squareds over here either, so that tells me that b needs to equal 0. So this is basically 0. Now as I look at everything else, I have 2a, so 2 times 8 is 16, plus the c term, cx, because I guess maybe I should underline that I'm combining my x's together, and it has to equal this x term, which is 13. So that leaves me with c must be negative 3. Subtract 16 over, you get negative 3. And again, b was 0. Well, d must also be 0 because there's no constant term over here. So I might as well write that down as well. D is equal to 0. So now I have enough information to solve my problem. Let's switch to black and just say, like, this is my answer. I realize that there's not much space. So my first term is 8x plus 0. Well, you can just write it as 8x over x squared plus 2. And then plus c was negative 3, so negative 3x, and d was 0 over x squared plus 2 squared. I do want to point out that you can go to Desmos and type in, I might as well do that right now. So I'm going to hit pause and just jump over to Desmos. You can do it with the graphing calculator, but Desmos is easier. So again, you feel free to pause, go back and double check your work. But as I just go over to Desmos, and I went ahead and graphed, I can move my screen over so you can actually, I thought I could move my screen over so you can see that I have them both typed, but I'm hiding the bottom one. Apparently I was hiding it underneath. But you can see as I highlight the second function, you can see that they fall directly on top of each other, which is proving that they are equivalent. I could even go to the tables and show you that you get the same exact y value for every x value. So we did this correctly. So again, feel free to pause the video at any point, double check that you have the right answer. as I show you the last one. So this is in improper form. This is improper because the numerator's degree is larger than the denominators. So we can fix that by doing long division. You know me by now, I'm a big proponent of long division. So as we look at this, I'm just asking what times x cubed give me x to the fourth. That would be x, and then multiply it. And then subtract off each term. What's nice about this is two terms go away. 6 minus 1 is 5x squared plus 20x plus 6. Now we can stop right there because this is now the remainder. So this is going to be part of my answer, x. So now jot that down. I already know my answer is going to start off with x plus, and then I need to start separating things. And the better you are at factoring, the quicker you can start doing things. So what I need to do is figure out how to break up 5x squared plus 20x plus 6. And again, if you can factor that really quickly, so x, and then I believe it's x plus 1 squared. So we have the linear term, a over x. And then, again, it's linear, so it's just b over x plus 1. But then it's c over x plus 1 squared. So I already know my answer is going to have, plus x plus something over x plus 1 plus something over x plus 1 squared. What we have to do is figure out what that is. So as you multiply everything by x plus 1 squared, the x would cancel, but this still has x plus 1 squared. You would have to multiply x. One of the x plus 1s would cancel here, so you still have the other x plus 1. And then the x plus 1 squareds cancel, but you still have that x. So as we're looking at this, we have 5x squared plus 20x plus 6. And just make sure you FOIL that before distributing the a to it. So we have ax squared plus 2ax plus 1 plus bx squared plus bx plus cx. I made a mistake right here. That should be plus a. I don't know why I forgot to distribute that. Which is actually part of your answer because there's only one linear term. You see how they all have x's or x squareds except for this one? So that tells me right away that a has to equal 6. So my answer, I know that piece right there is 6. Then probably the next thing I would look at is the fact that a and b, the only two x squareds terms, which we know a is 6, plus b has to equal the x squared term, which is 5, so subtract 6 over. B must equal -1. And there's only one piece left to find, and that's the c value, which is not as easy, but 2 times a, so 2 times 6 would be 12, plus the b term, which is -1, plus the c term, right there. See how all of those have an x attached to them? Have to equal 20, the x term over here. So that would be 11 plus 9. C would have to be 9. So hopefully you are fairly good with the arithmetic to get us there. And we have the final answer. So you can probably guess what I'm about to say is that you can check your answer with a graphing calculator. I know I didn't do that with the first video, but you could go back and double check all of your answers before turning it in. And that's just through the use of a graphing calculator or Desmos, which is exactly what I'm going to do. I already have the original problem graphed. I have my answer, and I'm highlighting and showing you how every point the graphs lie perfectly on top of each other. So that's how you can tell that you did this problem correctly. You can also use your table and see what the y values are, except a lot of undefined values here, which should make sense considering we just finished the whole unit on rational functions. And good luck on your homework.